So, here we go. The Common Core, it's G for geometry, CO for congruence, and it's number 1, which is basically no precise definitions of angles and parallel lines. Okay, there's our Common Core. And so far we're still stuck with the Common Core. I haven't heard anything different yet, so there we go. Okay, now right off the bat. So when I have this dark arrow here, that's telling us they're parallel. I mean, I could write L is parallel to M, but these dark arrows, you'll see the same thing in the book. It means they're parallel, okay? So when you see that, you know L is parallel to M, okay? So let's go ahead, let's do this. So give me a pair of alternate interior angles. Alternate interior angles. 3 and 5. Angle 3 and angle 5. Makes the Z, doesn't it? See it? Nice. There's another pair. 6 and 4. Nice job. And angle 6 and 4, okay? And I'm running out of room, but okay, we'll just put those, okay? Corresponding angles. Give me a pair of corresponding angles. Makes the F.
4 and 8.
4 and 8. Nice job. Angle 4 and angle 8. And there's a whole bunch more. You've also got 1 and 5, 2 and 6, and 3 and 7, okay? Alternate exterior angles. Alternate exterior angles.
1 and 7.
1 and 7. Nice job. And what's the other pair? 2 and 8. Nice job, you guys. Vertical angles. Now you guys know vertical angles, don't you? Say it again. 5 and 7. Yes. Angle 5 and angle 7. So to be at vertical angles, you don't need the parallel lines, right? You don't need parallel lines. Do not need. In fact, I can cross that. I can just ignore that guy, and there's a whole bunch of vertical angles, right? So you don't need the parallel lines to be vertical angles, right? Good. Same side, and I call it supplementary. Same side interior, but we're going to start calling it same side supplementary because the lines are parallel. So give me a pair.
3 and 6.
3 and 6, perfect. Angle 3 and angle 6, and of course the other is 4 and 5, okay? What's the transversal? Line T, exactly. Line T is the transversal. And all a transversal is a line that cuts two other lines, cuts through two other lines. In this case, it cuts through two parallel lines, okay? All right, so example 1. So let's go back and take a look at our picture. If angle 1 is 35 degrees, so if I put 35 degrees here, we should be able to find all the rest of the angles, shouldn't we? If angle 1 is 35 degrees, I should be able to find all the rest, right? So, well, angle 3 is 35 degrees, right? Angle 5 is 35 degrees because of the alternate interior angles. Angle 7 is 35 because of the vertical angles. I need a calculator then, don't I? Because I'm going to go 180 minus 35, right? Which is 145. So that means angle 8's got to be 145. 6 has got to be 145. 4's got to be 145. And 2 has to be 145. Does that seem as easy to you as it is to me? Thumbs up. Agree? Pretty easy? Okay. All right. Now, let's look at example 2. So right off the bat, I know they're parallel, right? I know they're parallel because of that, the darkened arrows. So I know they're parallel. So if they're parallel, looks to me like we've got a pair of corresponding angles. See the F? So corresponding angles are equal. So let's set these equal. 2x minus 45 equals x plus 30. All right. Minus 1x, that's easy. So I get a x minus 45 equals 30, right? Plus 45, x is equal to 75. Okay, now that's not the answer, the angles, that's just x, okay? So, may as well put it into here. It's easier if I put it into there. Put my 75 right there. So, 75 plus 30 105, yes. So easy, 105. That one's 105 because they're vertical angles, right? This one's 105 because they're corresponding angles, right? This one's 105 because of the vertical angles. Okay, now let's go 180 minus 105. What's that equal? 75? So that means this angle is 75. Its other angle is 75. Vertical angles. Alternate interior angles tells me that's 75 and that's 75. Thumbs up. Kind of sideways. Thumbs up. Okay. All right. Example 3. What do you know about these two angles? They're not equal. They added one, and this is where kids miss questions on this next test. They're not equal. They add up to 180, okay? They don't even look equal, do they? This one looks less than 90, and this one looks more than 90, right? So, but they do add up to 180 because they're the same side interior. So we're going to go 13x plus 23x equals 180 because they are supplementary, okay? What's that going to make? 36x equals 180. Good job. And divide by, let's see what's 180 divided by 36. 180 divided by 36, and I get 5. Okay, x equals 5, we got it. So let's find all the other angles. So let's put 5 into here. So if x is 5, let's put 5 right there. So 13 times 5, I think is 65, right? So this angle is 65. This angle has to be 65 because they're vertical angles. This angle is 65 because I've got my z, or my alternate interior angle. This angle's got to be 65 because of the vertical angles. And then let's see, what's 180 minus 65? What's that make? 115? So this angle's 115. 115 because of the vertical angles. 115. 115. Thumbs up. Sideways. Okay. Thumbs up. Good. All right. Ready to turn the page? Oh boy, a good old-fashioned algebra problem. Hey, look at this. 2 equations, 2 variables. We know how to do this. We do. It's kind of a little bit like our extra on the test the other day, but hopefully it's a little bit easier. Okay, let's see what we know. I need to get somehow this equation connected with a number, okay? I need to get this equation connected to a number. I know that these are parallel, okay? This is parallel, these are parallel, this is parallel, this is parallel, okay? I don't know, these don't look parallel, do they? But I can do this. Let me walk, I'm going to walk the 125 all the way up, okay? So you ready? 125, 125. Vertical angles, right? Okay, see the z, these lines are parallel, 125, 125. There's my z, right? This 125, right? And let's see if I can find my z. That's got to be 125. So I know that 25x plus 5y equals 125. I'm going to start right there. Okay, all right. Do that, all right. So equation 1, start off with equation 1 is going to be a 25x plus a 5y equals 125, okay? Yeah, it's a 5y. Now, let's figure out, let's walk this up, okay? So if this is 120, right? Do you see the z? Alternate interior angles, see the z? That's 120, okay? Because of the parallel lines. So here's my second equation, equation 2. It's going to be a 25x plus a 4y equals 120. All right, 2 equations, 2 unknowns. What do you think? Let's solve. What do you think?
Put a negative on
Yeah, let's just subtract. Totally agree, Claire. So if we multiplied this one or subtracted, if we just subtracted this from this, what's going to happen to the x's? If I subtract that from that, 25x minus 25x, the x's will be gone. All right? So let's just subtract. What you said, Claire, I liked even better. Bring through the negative, but we'll subtract. So 25x minus 25x, they're gone, right? Gone. 5y minus 4y is a 1y. 125 minus 120 is 5. So we got the value of y. Y is 5, right? Let's find x. I'm going to take my 5 and plug it into either the first equation here or here. Doesn't really matter. Which one do you want? First or second? Well, actually, this looks easier. I like that equation better. Doesn't that look easier? So let's go 25x plus 4 times 5 equals 120. So I plug, since y is 5, let's plug the 5 into the y, right? Mr. Bard showed you how to do this, right? 25x plus 20 equals 120, right? Minus 20 minus 20. 25x equals 100. How am I doing? Divide by 25x is 4. There we go. There's our two answers. A little bit harder. A little bit harder, but you guys did learn this in algebra. I know you did. Mr. Bard did a good job of teaching this. It's kind of nice because Landon's in Mr. Bard's class, so I can see if he's a good teacher, and he is. Landon brings home good stuff. I'm like, hey, I like that. Every now and then he does one of these problems of the week, so I'm like, what is he talking about, right? Okay. 5. So we're given, it's a proof, but we can do this. Okay, step 1. If the lines are parallel, then we know the angles are equal, right? So step 1, let's go ahead and go L parallel to M, and everybody should know the reason. Everybody should know this reason. What's the reason? Given. Okay. Now, number 2 here says something about a vertical angle. Okay, so that's a hint. I think I see a pair of vertical angles up there, don't you? How about 1 and 3? So let's say angle 1 is congruent to angle 3 by the vertical angle theorem. Good. Okay, now 2 is equal to 3. Where'd that come from? Nah, let's go back to our parallel lines. Let me draw a picture, okay? Let me draw a picture. What do you see? It's corresponding. Nice job, Kurt. It's the C, which is the corresponding angles. So we're just going to go C-A-T for corresponding angles, okay? Now, you ready? If I'm as cool as Mason's as cool as Kurt, then Kurt and I are as cool as each other, right? So if 1 is equal to 3 and 3 is equal to 2, what can you say about 1 and 2? By transitive, right? So I'm going to say angle 1 is congruent to angle 2 by transitive. Or you could say substitution. They're kind of almost interchangeable. Okay, how was that? It wasn't such a hard proof, was it? So homework today. And please draw the picture, show the work, right?